Alrighty. So last night we spent some time going through reading about these books, the BPF Performance Tool book and the Systems Performance book, just to kind of get a vibe for like what we're getting ourselves into. And I was thinking about it last night after the stream and a little bit this morning. Like, is this the right path of learning for me? Right? Is this the right next step? Like, I know BPF tooling is going to be something that I will make heavy use of in my career to debug and analyze performance, but also just to understand systems. And instrument systems for understanding their performance. So I'm wondering, okay, well, do I want to learn those techniques now? I mean, there's so much available for me to learn just in the stack of books I have next to me that I've already purchased. And this book was like next on my list here, which is the Computer Systems book, A Programmer's Perspective. And I was listening to this guy, this Coding Jesus guy, his YouTube channel. He does kind of mock interviews for quant candidates, quant engineer candidates. And the amount of detail that these candidates knew about CPUs, memory management units, like low level details of how computers operate. I don't think he's ever touched on GPUs in any of the interviews, but he's certainly, I mean, he's a C++ guy, so he does a lot of C++ trivia and knowledge checks, but then he goes like into like your understanding of operating systems, your understanding of basic CPU fundamentals like protection mode and how the memory management unit works and how caching works, like what are the latencies between L1, L2, L3, main memory. And these are all things that I'm like familiar with. But he asked this candidate this morning, like, how would you measure the latency, the difference in latency access between L1 and main memory? And I was like, shit, I don't know how to do that. Like, I know in theory, it's several orders of magnitude, potentially in like the speed at which you can access data from cache or registers up to like main memory. But like even just cache coherency protocols, like it's something that I'm like just I've touched on it in my learning here and there, but I don't have a deep understanding of this stuff. And if you were to ask me to like detail like some of the specifics about like cache coherency or cache access, like that's stuff that I just don't have a solid understanding of, the low levels implementation details of it. And I was thinking this morning, I was like, damn, like I really want to read this computer systems book. I feel like this is the piece that's missing for me to understand these things better. Like every time I open this book, I'm like, oh my god, there's just like so much assembly in here. I love it. And I did a little bit of reading assembly on stream like a couple of days ago. What were we doing? Why were we reading assembly? It was some God bolt thing that we were doing. Oh, I was trying to like figure out how the compiler orders the allocation of local variables on the stack, and basically there's no guarantee in any of the ordering. And then I was using negative indices into an array to try to like poke before and after the array in the address space. And what's funny about the address space in the stack is that it's going down, so like negative would actually push you further into the stack. But we're testing bounds, exceeding the bounds of an array on the stack, and if we could read other bits of, and of course you can read other bits of memory, but like I was trying to figure out like an intuition for how the compiler is laying out the stack memory. And we disassembled that, and we were able to figure out, oh, the compiler just does whatever the hell it wants because there's no guarantees in ordering for those things. So it'll like, put your variables in whatever order it wants. If you want to enforce an ordering, use a struct. That was my like intuition, was to just use a struct, and then all the fields would have a guaranteed ordering. With the alignment padding and everything. But outside of a struct, you can also just allocate a byte array and then get pointers into that array and then cast them into the types that you're interested in. If you know the sizes and everything, obviously. So we've done a little tiny bit of disassembly using Godbolt and objdump. But like looking at this book, it's just all hardware concepts and some C programs, but a lot of assembly. And I was reading through the indice on this. The index on this, and they have a section on operating system I/O, like system level I/O. And I feel like that whole section I can skip. The network programming section I can skip. These are like a lot of things that I already understand. Even the concurrent programming stuff, I mean, I might get a lot out of that, to be honest. Even though I've done concurrent programming for many, many, many years now. But the things I'm interested in are virtual memory section. I haven't really spent a lot of time in like understanding. I think it's called the TLB, table look-aside buffer. Yeah, that's not what I wanted. So like he mentioned this in one of the interviews, and I'm like, oh shit! Like I knew the memory management unit was responsible for like mapping, virtual addresses to physical addresses. It's a bit of hardware. Sometimes it can be implemented in software in the operating system, but really for performance, you need it in hardware. And I was like, okay, I'm aware of that memory management unit, but the actual details of like the translation look-aside buffer, that's not something I've ever really dove into. Let's see if it's even in this book in the virtual memory chapter here. Yeah, TLB. Speeding up address translation with a TLB. There you go. So there's a lot I would get out of the virtual memory section. Exceptional control flow, just the memory hierarchy, having the memory hierarchy like solid, and like doing exercises around measuring the latencies of different memory accesses and cache accesses. Like I feel like that would be a really great learning experience for me. Even some of the linking stuff, like this is like operating system stuff, but like, I know very little about the dynamic linker or even like the static linker in the compiler. Like, or I guess static linker is separate from the compiler, but you get what I mean. When we're compiling a program and linking, there's a static linker that gets invoked to link everything together. I know very little, but I know you have to do stuff with like relocations. The dynamic linker, again, I don't know very much about. So there's even a section on optimizing performance. They have this Y86 kind of mock assembler language that they use in one section to describe the process architecture, machine level representation of programs, representing and manipulating information. There's so much in this book that's like stuff that I know enough to know about it, but haven't really spent time intimately understanding it. Except for the I/O stuff, I feel like I have a good grasp of I/O and networking at this point. Having read the Linux programming interface and having like implemented epoll file server, and just like working for several decades now in like an environment that's heavy in networking. Like I understand networking concepts pretty well. So I think what I'm going to suggest doing with this book is, instead of just diving in and doing it like cover to cover, like I've done some of these other big books, I think what I'm going to do is I'm going to read sections of it. Yeah, I'm not going to be a completionist on this one, because the sections on IO and networking, I feel like I could probably skip and be fine without reading. But some of these other sections I really want to dive in and like understand things at a lower level detail. And then going into this BPF performance tool stuff, like this diagram here, he has virtual file system, VFS, file systems in general, volume manager, block device, sockets, TCP, UDP, IP, net device. I think all of that stuff I would be pretty comfortable instrumenting. The operating system scheduler, like, I don't have a good grasp of scheduler concepts. Virtual memory, again, don't have a great grasp on virtual memory. Everything at the system call interface and above, I think I'm pretty good at. Networking, device, block device, file systems. Yeah. So like actual CPU details is what I'm not good at. CPU and virtual memory. Like I have touched on the ideas of like pipelining and out of order execution and speculative execution and like all these other CPU concepts, and I could probably explain them to like a layman or someone who is kind of like in a programming related area, but it's very surface level explanation, and I feel like I want to go deeper. I want to have a better fundamental understanding of how CPUs work, and the hardware surrounding the CPU. Yeah. And I feel like BPF is like something like this book, the BPF performance tools. I'm not saying that it assumes knowledge of that, but like, you know, there's a whole section in BPF performance tools on virtual memory. Let's go to the index here. Memory 243. So let's skip over to the subsections. 243. So there's a section, background, memory fundamentals, BPF capabilities, strategy, bunch of tooling. So that is very, very much a get to instrumenting your system type chapter. Let's see what it has in this other book, 303. Now let's go over here, 303. All right, so this one goes into virtual memory paging, dynamic demand paging, overcommit, process swapping, file system cache usage, utilization, saturation, allocator, shared memory, working set size, word size, architecture, hardware, software, project, process, virtual address space. Like, bro, I don't have the confidence to just dive into some of these things and start instrumenting stuff. There's just two ways I can go about approaching like an area of technology, and that is to operate in my place of ignorance and try to learn enough to get certain objectives accomplished, and reach down in the stack only deep enough to get the things that I want accomplished, without developing a fundamental understanding. The other approach, which is an approach I've taken several times in my career, is to say, fuck all that. I'm going deep at a fundamental level and building up. Instead of starting from a place of ignorance and trying to create a foundation. It's like building a house. Like, you have this goal of building a house. You don't start with the roof and try to build down to a foundation. It wouldn't make sense. It wouldn't work. The building would fall over. Now, learning is obviously, it's an analogy. So learning is obviously not necessarily, you're not going to fail if you take that approach, but it's just less stable of an approach. And when you're dealing at a high level of technology, the level of abstraction that you're operating in is just so freaking high that, yeah, you can live up this in this world of abstraction, but it's just like eventually the layers below you are going to reveal themselves. You are, no matter how many cloud servers you own and operate, like you are, or how many lambdas you run in AWS serverless Lambda services, like ultimately you're running on CPUs. It all comes down to CPUs and GPUs and other hardware. And so I'm interested in these fundamentals. I want to know the fundamentals of CPUs and GPUs, and I want to build up from there. I want to build up an understanding of algorithms, of operating systems, of everything above the hardware. But I want to start with the hardware. So I think that's where I'm at. I kind of took a whole 360 approach here and deciding what I want to learn next. You know, I started with this book, and then I had this kind of crisis moment where I was like, shit, I need to do some work to like prepare for interviews. And that's when I kind of panicked, and I like threw the systems performance and BPF performance tools books on the top of the stack, along with the cracking the coding interview and all that stuff, because I want to be able to perform well in interviews. I am going to be doing more interviews this year, and I want to be able to perform well. But I guess I need to like ask myself, what do I want to do with my life here? Because I've hit a level in my career where I've had a lot of success, a lot of financial success and career success, and I can continue down that path. And then, you know, I'll be 60 and retired, like actually retired, and like looking back on my life and just not feeling accomplished. Because I just kind of like iterated in my little space, you know? Whereas going down to the hardware and building up, it's like my brain will change substantially. Synapses will be formed and destroyed in this process. And I will have a better understanding for how computation actually works in the world versus where I'm at now, which is dealing in levels of abstraction. So I'm saying all this just to say, like, I'm going to be reading the computer systems book next. I'm not going to be reading the BPF performance tools book, even though I think that would be more beneficial to me if I want to interview shortly, like soon. And the other thing I want to say is that I'm going to take an approach where I read the stuff that I feel I'll get most value out of. Because any book, especially a book of this size, there's going to be whole sections that you're not going to get a lot of value out because you already know the fundamentals of that area. And so operating system IO and networking, I might just skip those entirely. So yeah, that's where I'm at with this. My learning objectives is going to be to complete this. It's about 1,000 pages. This is going to be a 50-page per day book. So that'd be 20 days. So it'd be a month. This will be a month project. And you know, probably less time than that, but that'll be pretty much the end of the quarter. So it is February 22nd. So at the end of March, I will be done with this book. Yeah. Okay. I have about a little under an hour. I have a meeting I have to go to this afternoon. And Yeah. I also wanted to get some food in me. I'm not going to take a break now. Well, I'll take a quick break here just to grab some water because I'm thirsty. And then I'm going to start setting up this project. And what I'll do is I'll just go to number 3 here. And we'll jump to learn log. And go in here. I'm going to push this BPF performance tools back down here. And then we're going to pull up computer systems to the top. And we'll start working on that. We'll say active and completed. Oh, no, we need to do 3 here. Sorry. Okay, so blogs. Oops. Talks. Boop. Active completed in the queue. Documentation. Active completed in the queue. Courseware. Active completed in the queue. Problem sets. Active completed in the queue. So we moved that C10K problem blog post into the queue. We moved the talk. That wasn't a move. I guess it's new though. We haven't committed it yet. Yeah, let's go ahead and do that. Let's open up here. What I'll do is I'll just say LSHLA tree. LT, sorry. What I'll do is I'll delete this talk for now. Or we'll put it in the queue. For this commit. Okay, so we have our active completed, moved into the queue, active completed, added to the queue. Active is now computer systems. And BPF performance tools is pulled up to the top. Active completed, active completed, active completed in the queue. All right. Get status. Say update. Active completed. Okay. And then in README here, we're just going to move this talk into active, and we'll keep that in the staging index. Get status, or just the dirty directory here. Cool. All right, so our next project then is going to be Computer Systems, a Programmer's Perspective. Sorry, let's go to AI and say, hey, is there a well-known abbreviation for the book Computer systems, a programmer's perspective. Show me an example GitHub repo. So it's called CSAPP. Cool. MKDAR CSAPP. Get init. And I'm going to copy the K&R C README to here. And of course, it's going to be totally different. So this is title dash authors. Computer systems, a programmer's perspective. Randall E. Bryant and yeah, it's an and David R. O. How to run. Okay, first I'm reading computer system Hey, I read that one too. Three E, I guess third edition. I guess it's the actual website here. So are these professors at Carnegie Mellon? Founders University Professor of Computer Science Emeritus. Okay. If we go to look up some biography for, say, this guy, I guess the main author is Randall E. Bryant because he's first. Please go over there. Thank you. Oops. Let's grab this guy out. Unlock with this and send this to 4, 3, 3. No, 2, 4, 5, 6. Where's my shit at? 3. All right. There you go. You go over here. Bam. All right. So we're going to look up this gentleman, Randall E. Bryant. If we can select the appropriate text. Let's see. Carnegie Mellon. Oh god, that dude's jacked. He could have been a bodybuilder. Alright, cool. So it seems like it is abbreviated CSAPP. Uh, well, I can go to like gist.github.com and just like do like test.md here. Sorry. File name test.md. And we're going to do, what we'll do is throw this whole entire thing here. And we're going to hard break it. Like it could be more appropriate to break it here. But will that continue the title is the question. Nope. And then if I do like that, it does two separate ones. So no bueno. And of course all these are no longer relevant. And we'll do chapter, how many chapters are there in here? Oh, they just get right into the main index. They don't even have a summary of contents. Okay, dokie. Oh, there's a TOC here. Can I copy from it? Hey, I can. Cool. Actually, I probably shouldn't have done that. We'll do that. Okay. How many chapters are there again? 12 chapters. Okay. Oh, no, it's part 2. Chapter 7 is linking. Make sure I'm getting these right. Alright. Tor computer systems representing and manipulating information, machine level representation of programs, processor architecture, optimizing program performance, the memory hierarchy, linking, exceptional control flow, virtual memory, oh, I did it again. Virtual memory and then system level I/O. Network programming. Concurrent programming. Are there appendices? There are. Error handling. Okie dokie. Oops. Let's back out of that. Who's this dude? Dmitry Moisev. Lab assignments. Welcome to the repository for the book Computer Systems Programming Perspective. This repository contains all the necessary instructions to set up your development environment and start working on the labs. Was this actually for a class, maybe? Did he do the initial commit or did he fork off it? Yeah, he did. So I guess he works probably at Carnegie Mellon, I imagine. Or it was a TA or something. So getting started, follow, do a download the Docker image, run the Docker container, VS Code, select dev containers attached to running container, choose CS app, or if you prefer to work in a browser, git clone inside the container, the book, student site, video lectures. Oh, there's lectures. Look at that. Interesting. Let me zoom out here a little bit. Why does that not want to zoom out? There it goes. God, I have to ban so many freaking spammers on Twitch chat. It's such an annoying thing. Alright, so it looks like these are all 2015 fall Intro to Computer Systems. So what if we grab this? Okay, that's the Jack dude there. Am I getting audio? I need to figure out the audio latency.
I'd like to welcome you all to this this term's instance of this course is officially either 15213 from computer science or 18213 from electrical and computer engineering. But a large number of the people enrolled in this course are in one called 513, which is
This is all 2015 stuff. Okay. Well, it's a good thing we pulled up this. I thought this is some random dude's like repo for learning, but I think he's a TA or a professor potentially at the school, Carnegie Mellon. Check your progress to the labs by checking the boxes below. Data lab, bomb lab, attack lab, cache lab, proxy lab. So maybe I should approach this differently. Maybe I should, like audit the course. But actually do all the reading as well. I mean, this repo is only 2 years old. This is still fresh, pretty much. So I'm going to say, hey, this is a great resource. We'll say labs. And then we're going to have a section on lectures. I don't like that this is a ASP site. passing things in like, what is this called? The what's it comes after the hash? What is the bit that comes after the hash sign on a URL called? The tag or something? Fragment. Yeah, fragment identifier. I mean, this isn't really like standard format either. Like usually fragment is like a symbol that then goes to an anchor inside of the, like an element with that identifier inside the document. This is kind of like treating everything after the hash as like a query parameter. Anyways, so we got our lectures here. That's great. Wow, this is a really great website. So I'm going to say student site. Let's close out of these. I'll come back to the labs. Webasides. Curriculum. Introduction to computer systems. This is the actual course website. Here's the labs. Of course, I don't have access to that. It would be nice to do an actual like course. This repo tracks my work on CM, Carnegie Mellon. Usually a syllabus will have like the course identifier, right? It's called 15213, I guess. 15503, 513. Let's see if AI knows. In this string, oops, please go away 1Password. Oops. What does 15 mean? Okay. $15,213. Oops. Okay, this is going to be a link. Boop, 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 boop. This repo tracks my work on Carnegie Mellon 213 Introduction to Computer Systems coursework, including reading the textbook CSAPP 3E, lab exercises, and video lectures. And we'll just do boom, 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 boom. Boom, 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 boom. Oops. I don't even know how that happened. But it did. Okay, we'll break here. We'll delete that. Okay, good. Okay. Interesting that they have a graduate version of the course, but I guess I don't know exactly why they don't have any of that material on the website here. I guess maybe that's we got to pay Stanford or Carnegie Mellon for. Okay, so these are the labs. If I go to labs. There we go, labs. We'll just do it like this. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lectures are... There's quite a few lectures. Can I inspect here? Is there a way of grabbing this really easily? So there's span, detail title. We'll just grab all the detail titles. So we do console here, do document.query selector all. Give it the .detail title. And then say for each. No, I can't do that. So he's actually giving a node list. So for var n of, I think you say of that. Say console.log n. And then here we'll say text dot inner text. I think that's how you do it. There we go. Look at that. Of course, this is going to be a little bit weird, but maybe we'll just do, instead of all this garbage, we'll say hey, s dot append of rs is equal to empty string. I think I can append. Just do plus equals. And let's be inner text plus the new line character. And then at the end we'll say console.log s. Okay. Got some duplication going on, but I can sort that out real quick with sort. Okay, so we Wayland paste into sort unique. Should get us just the actual things, and then Wayland copy, killed that, go down here, paste it in, and then we'll go boom, 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 boom. Recitation. I really like the recitations. It's my favorite part of auditing these courses. But it starts at recitation 3. That seems odd. Can I search here just for recitation? Wow, very performant. So we got 6.4, 14. Oh, look, it's recitation 14. Can I sort by, sorry, sort by name? And of course it's going to do a weird sort. Okay, so I think what I need to do is back out of this, sort by name. That'll be good. And then you see results per page. I need to bump that up. These are rookie numbers. There we go. Now I can go into my inspect console, and we're going to rerun that program. And we're going to get some duplicates. That's fine. Fine. Grab those, go back over to here, do our Wayland stuff again, go down here, and kill all of this. 10, 11, 12, 13, 14, 15. You go here. Where's recitation 1 and 2 though? Is there no recitation 1 and 2? Roll 0. No recitation 1 and 2. That's a bummer. Let's search for recitation again. And then sort by name. So recitations go up to 15, but they start at 3. And if you go to the syllabus here, class page for list of okay. I'm at the class page. Home. Take me home. Introduction Data Lab. This is a Bomb Lab Part 2. Okay, well these are the lectures I'm going to review. Seems to be a reasonably complete set of video lectures. Okay. Okay, so I'm going to back out of this, jump back over to learn log, update my README here. So this is actually going to be a courseware. I'm going to mark it as active, and it's going to be Carnegie. I don't know how to spell Carnegie Mellon. Carnegie Mellon. And this will be 15213. 15213. And it's going to be on Introduction to Computer Systems. And we'll give the course website here, which I believe is just this. We'll say notes, even though it's not notes. But we'll do it anyways like that. So I don't want to name this after the book. I feel like that's a little bit strange if I'm going to be doing this as a course. But the book is really where I started with it. And I discovered the course material as a companion to the book versus being the opposite direction. So maybe I will just continue it with the name that I gave it, which I believe, if I cd dash was CSAPP. CSAPP. And then here, oops. We'll leave that for now. Get status, get add P, and then what I'm going to say is like no, skip. I think it's no, yes. Oh, and I need to update the location for this, the notes for that, computer systems. So let's go back here. Yoink that. Books, computer systems, bam. Oops. Oops. Like that. No. Yes. Get status. Get CIM. And we'll say hey. Add CS app stuff. Get push all. See back over here. I'm about to create these repos now. Codeberg. Oh, we'll do GitHub first. GitHub. Boom. New repo. We're going to call this CSAPP. And for cat.readme. I don't want to do a description. CSAPP. Create repo. Get status. Get status. Okay. Get add readme. Get status. Okay. Let's go ahead and have our thing go like that. Get push u origin main. Huh? Get remote add origin. Get remote. Verbose. Get push. Oh, it's because they have main instead of master. Okay, and then let's do Codeberg. And we're going to go here to create a new repo. Repo name is CSAPP. Advanced settings. Click to expand. Default branch will be master. SHA-1's fine. Create repository. And then we'll do this. Yeah. But we're not doing it as origin. We call it Codeberg. Get remote add Codeberg. Get push Codeberg master. Get push all. Okay. Okay. Nice, 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 nice. All right, I have about 9 minutes until my meeting, and I didn't get my water like I said I would. Oh, someone canceled the meeting. Interesting. Let me check in on that. Oh, okay, someone canceled it. Well, that's good. I get an hour back in my day. Nice. It's just a thing that I do with some people for accountability. It's not even like super stressful or anything. It just usually after the meeting I'm a little bit distracted, we'll say, from actually getting stuff done on my learning objectives. So all right, I'm feeling a little bit run down right now, to be honest. This morning was a bit rough for me. So yeah, I'm gonna take a break anyways to get my lunch in and get some cardio in. It's been a few days since I've done cardio, so I need to get my cardio in, and then I will hop on afterwards to start on the course material here. Yeah, I'm happy that I found this course material along with the book. Makes the book a lot more approachable. Let's see what else they had up here. So these are lab solutions. I don't really need that because I think I can come up with my own solutions. Yeah, this is someone just recording their own solutions 6 years ago. And then lab assignments and notes. This was 7 years ago. Four years ago. Same videos probably, yeah. Same website for the book. Lab assignments. That's a different website. Huh. Well, let's go ahead and just go into here, make sure we got our labs set up here legit. So there's a data lab, bomb lab, attack lab, buffer, architecture lab, cache, performance, shell, the malloc stuff, proxy, and I don't know what SFS is, so I'll just record these. Okay. $10 ago, wow. Okay. So I think what I'll do is I'm gonna hop off, get lunch, do cardio, fix my HDMI audio so that I can actually watch videos on stream from my workstation and the audio isn't out of sync with my stream machine. So I'll do that off stream, and then we'll come back and we will watch this first lecture to get our brain juices flowing and then start diving into the book. Cool. All right. I will be back on probably a couple hours, so probably about 1 p.m. my time.